Um, Good evening, guys. So today we will write few more MapReduce jobs just to get a hang of it. Different problem statements. So let me show you maybe a couple of programs like inverted indexing problem and then TFID, term frequency problem. Okay, and then you can do the rest of the problems, vowel consonant problems, and those stuff. So vowel problem or consonant problem. The last class, I think I have given you one problem statement that I want.
So, are you recording it?
Yeah.
Sorry to interrupt. Are you recording it? No,
Yes.
I don't think it's coming there. It's
I
not.
think it is.
That red button is not there.
It's all. It was. Anyways, I know I've started recording. Right.
Yeah.
Okay.
Thanks.
So we will write. So in the last class, I have asked to write one problem that output only the words which are starting with the vowels, something like that. So we will do a couple of problems today to just to get a hang of it. And we
Uh,
will uh, write the problems using the um, tool. The same way I'm gonna do that. And let us give the name. First, I'm going to start with the inverted indexing problem. I hope you know what we do in the inverted indexing problem. So it's basically we search a word and we try to find out that in how many documents the word is appearing. It's fine. Actually, I don't have to create. I could have taken my the previous word count problem and I can create a new package out of it, right? So com.training dot I can get a new package. Com.training dot inverted indexing. Ideally, you should create a new project. I'm just creating a package and I will be putting my mapper and reducer class over there. In the last class, I have already shown you that this driver class become very generic and we can use our conf file just to set everything whatever we want. Yeah. Now here I'm gonna write first my inverted indexing mapper. I hope you know. I'll go I'll go a little bit fast here today because we know what is output key, output value, and everything, right? From the mapper and Redis as well. If you have not if you don't understand or if you have not gone through inverted indexing, I strongly suggest that you should go to lecture number 13 and lecture number 14 to understand that what is inverted indexing problem and what are the output key value pairs from the mapper, what are the output key values from the reducer, and also to check what will the data types and understand until we will be using the same input format for a couple of problems. That's a default input format. That's your text input format. This is my class name and it should extend from my mapper class. So org Apache Hadoop MapReduce. So that's my mapper class. And okay, inverted indexing mapper. Okay, why it has okay key in value in, key out value out. Okay, the key in will be long writable since I'm using the text input format. So input key long writable, input value would be text, and I hope the output key value will be a word which will be represented as text, and the output key and the output value will be the file name. So it will again represent it as a text. Then I am gonna right click here, go to source, override implement methods, and I need my map method. So I select this map method and OK. And now I am ready to write my map method. What logic should go inside this? Okay, it's okay to remove this, so I'm removing this context. I don't want to call the super. I will call my own method. Right. The first and the foremost, I need to know. We need to know. So we understand that map method gets one record from an input split, from one input split, right? Everyone understand that input split or a block. Now, once you get that, um, we need to find which file this this record belongs to, or basically we can say which we need to find which file this input script also belongs to, because record is belongs to input script, so we can say that we need to find out which file this input script or block belongs to. That's the first thing, and you can find out using the context object. I believe context dot get input split dot. Okay, let me just check using input split. You can get it, and you say input split dot. No, not this one. Context dot get. Okay, let me just, before I go ahead, I will also download the source code uh, to of Hadoop. I'll download the source code just to, in case um, I wanted to see that how to get the input split from the context, how to get the file name from the context object. So this is how you can download the source jar, and once your source jar is available, then you will be able to log in. You will be able to actually see the code. What is happening behind the scenes. So that's the way you have to get input split. Then you have to file split. Actually, this was the guy I would have. The input split would be an abstract class, I believe, or the interface. I think so. So then you actually do a file split and get back. Okay, but let us confirm that once. Now let this the downloadation of your source jar continue, and then we will see. We will see what exactly falls behind the scenes.
So
Yeah.
One question. Actually, this is the first time I have used Maven dependency sources. So, first we create the Maven project. In the same project, do I need to run this command, Maven dependency sources?
Yeah,
Okay. Okay. Thanks so much. I'll try it today.
seems to be slow net. Yeah. Nevertheless, what I will do, I'll cut, copy, paste this code path. So the file split is org Apache Hadoop MapReduce. Always you have seen that there are two files with the same name. So I'll choose with the packages of MapReduce. Path org Apache Hadoop IO, sorry, org Apache Hadoop FS. That's your path, and now you have the file path, but it gives you the entire name, big name, HDFS colon slash slash and everything. So get name would actually give you the smaller name. Get name. Okay, now you have got this name. The job is very simple. You can actually string input record. You get it right. So you get your input record. The rest of the things value of two string. Now you break this record into words. Word array input record dot split, and the regular expression would be slash slash w plus. And once you have this, you iterate over the each of the word array. So with every iteration you get a word of type string, you get a object of string. If word dot length equals to greater than 0, you are basically trying to not to count the space. You're trying not to address the space, so that's why this uh, condition. Now, once it is done, now your context dot write new text of word, comma, new text of the file name, and that's it. Your job is done. But every time you see that, right? This will work. There is as such no problem with this. It's gonna work. But my only worry is that for every word, this new text, that means every word, the when it is doing the iteration over this word array, for every valid word, it is going to create an object of a text, and then you are sending it, right. Instead of that, it's the best idea that you create this object only once and reuse this object over here. For that purpose, I'm going to create a member variable, private text. My I will say output key as mine with the variable object name, and also private text. Very sorry. Output value is also first, so that's my object name. And what I'm going to do here is I'll just say, instead of doing this, so this object has been created, I will just reuse this output key dot set word. So you are creating only one object and you are reusing it. Set file name. Okay, I got it. What it is going to say, output key dot set, you have to do it before, because output key dot set is an a void. It will return type a void, right? So you have to do it before, and then you can actually output key. I'm very sorry. Output key output value. Okay, so that's it. Your job is done of the map of the mapper. Now what you need to do is to write your reducer. It will extend from your reducer class, and key in will be text. Key out will also be a text because that's output key of the mapper becomes the input key to reducer. Output key, output value of a mapper becomes the input value to reducer. Also the reducer final output key will be the text, that's the word. And what will the value? Value will be again the list of the file names in which the word has appeared. So right click, source, like in key, values. It's okay to remove this till this here. It's okay to remove it because in the same method, so it's okay. I mean to say on the same class. That is fine. Now you get a list of values here, which are the list of values are nothing but the values, the data type values, whatever written values are nothing but the list of file names or the file names. Yeah, then we can say the list of the file names where the word is appeared. And there is a possibility of duplicate file names as well. There's a possibility of course, there's a 100% possibility of duplicate file names because a word can appear in multiple files, right? The word Aaron can appear in, for example, I'm going to run this on my Shakespeare data. So the word A or Aaron or a common word can appear a lot of times in the same file, right? So that's why I'm written duplicate file names, and but we want to appear, but we would like to display it only once. So for that purpose, I'm going to take a hash set so that keeps the unique values. Hash set of string, or what do you want to say? Hashtag of text, let's say. Text file names equal to new hash set. And now you iterate over your file names for text file colon, okay, file name colon values. So first and foremost, I will check whether my file names unique. I can refactor it as rename it as a unique file names, unique file name list. It's okay. Does it? This variable makes sense. So I'm checking if unique file name list contains my file name. If it already contains my file name, don't do anything. So I'll put a not condition. If it does not contain the file name, I'm gonna put my unique file name list dot add the file name. So if it does not contain it, put it. That's the first thing, right? So you are done with um, your for a given key, whatever given key, you have got the list of the file names by this, right? Now, what you can do now, what do we want for a given key? We want the output like this. For example, for a given key, we want output like file 1 comma file 2 comma separated file 3, right? I wanted something like this. Okay, so what we can do now, we can unique file names list dot uh, can I convert to array only? Dot to array. Okay, no problem. I can do something like this: string builder equal to new string builder. The reason I'm going to create a string builder is just to add the names. So whenever to say builder dot append the file name, every time it comes here uniquely, I will append it the file name and I'll append with the comma, right? So every time the file name comes, I'm going to check whether it's already present or not. If it is not present, add it to my hash set and also add it to my builder. So once it is there, once you have created this, then you need to get the, then what you can do, builder dot, because at the end there will be one more extra comma, right? At the end there will be one more extra comma, so you need to builder dot, I can take a length minus 1 dot substring 0 to builder dot toString dot length minus 1. That will give you the list of files, list of file names as string. I hope this will give you the same. You are trying to you are first consider the string, then you are taking the substring, and then substring from 0 to length minus 1. I think that should be fine, I believe. But if you are not, then let us do a quick check whether it's gonna work or not. So I'll create a sample public static void main, and then we will say string builder builder comma new string builder, and I'll just iterate for 10 times I is equal to 0, I less than 2 or I less than 3, I plus plus. Okay, and with every iteration I'll say builder dot append string dot value of I, right, and dot append comma. I'm doing this, right, and the same iteration I'm doing this. I just wanted to say CISO builder dot toString. Let me run this. You will see that at the end there will be one extra comma which we don't want as an output. 0 1 2 0 1 comma 2 comma 3. I don't want the extra comma at the last because just should display 0 1 2 3. So what logic we have actually implemented? We have wanted this, or we have actually implemented this. Let us see whether you can see that the last comma has been removed. So that means this logic gonna work. And then you context dot write, the input key becomes as is the output key, and the input value will become new text of list of file names. Again, you can reuse it the variables. So I can say private text output value new text of, okay, I will say output value dot set, and then you use this output value. Yep. And that's it. Your job is done. So you have written your mapper, you have written your reducer class, and now it's a time to run. I can use the same driver code here to run my mapper and reducer class, and I hope everyone are aware that how we'll run it now, right? So we have our conf file. Refresh. If you see that we have our conf file here, and it will be changed for every if you want to run it for, let's say if you want to specifically keep it for your what count conf xml, so let us keep it for what count conf xml. Okay, let me just rename, and this I'll rename as a word count conf. I will just cut copy paste, and then I will rename it as a inverted indexing conf, inverted indexing conf.xml. Okay, and then what I have to do is I have to okay, the properties change. I'll just change the property names. I hope these properties remains as is. We don't have to worry now. Okay, cluster name, queue name, and the resource manager. That's your sorry. The address of name node, address of resource manager remains the same. Mapper class. This will gonna change. So what is that mapper class for the inverted indexing mapper? It is copy qualified name, and here it will be inverted index mapper. Similarly, the reducer class, copy qualify name, select your class name, right click, copy qualify name, and then go and paste it over here. Okay, number of reducers, you want to run how many reducers, it's up to you. Let me run as a one first. Then output key class is text, and output value class from my mapper is also text. I'm just paste what happened. Text, everything is text, right? Output, this is your output key class from your reducer, and this one is your output value class from reducer. Everything is a text, so I've just pasted. Input format is a text input format. Input data will be same as my input data, and but output directory I'm going to change as a inverted indexing output. So that's my output file name, and that's it. My job is done. So what we're going to do now is, okay, let me first see whether my cluster is running or not.
So,
Yeah,
hello.
yeah.
Yeah. So in last session, we specifically in the driver class we passed those parameters. So instead of that, today we are passing as a .xml, right? Those parameters
I,
for
I
the
think,
program, driver program.
yeah, in the last class itself, I have shown that how to pass the parameters using the tool runner, and also how to pass it from configuration file.
Uh, Tool runner. Okay. Okay.
In the last class, I think the other day when I told you that Monday will be a class, I think I have not followed up, so no one joined. No one joined in the sense you guys didn't join. Khushbu and Shanavas, they joined actually.
Oh, is it?
Yeah.
Okay. Maybe then I have missed it. Yeah. Sorry.
Now let me start this instance state start. Yeah. It will take some time to start. Meanwhile, if you see that here, my okay, I will also run this Maven Eclipse colon Eclipse, and this time you will see that we have already downloaded the source jars, so we can see actually how to what do you say how to go through this, how to see the code of Hadoop, what happened behind the scenes. If something you want to understand, then you can actually go through the source code. So if I wanted to go to invert indexing mapper, I wanted to see what is this get input script. So if you see that this is an interface, and that's why, okay, this input split, so public get input split. Okay, so this input split is an abstract class, so that's the reason. Now abstract class, I put a command T, that's your shift. I don't know what is a, in Windows it will be control shift. So when you put a control shift T, then it will actually give you which all classes have extended from this input split class. So the one which we are looking out is this MapRed. So when you go inside this file split, you actually see that how it gets the path. So this is the get path which we have called to get the file. But then file split is working like this. It actually takes up the file, the start, the length, and the host. Host is nothing but who are hosting those. But it's the start of the start position, first byte in the file to process. Length is the number of bytes in the file to process. It keeps tracks of everything. And this file split is extending from inputs and implements a writable. That means it will have an serializer and deserializer as well, which has a, I believe, which has a read and write method and read fields. So these are comes from your writable for serialization and deserialization. Okay, so that's fine. So what we're gonna do now is to run our code on the cluster. So before that, we have to start our HDP. We have to start our cluster. What happened here? It started or not? Okay. This is our jar, rmnsf word-final.jar, and I'm gonna, have I build it? Yes, I think the last command I have. Okay, let me build the code here. scp minus I. HadoopDeveloperTraining-Lecture target what counts snapshot shaded.jar to EC2 user at, let me restart it. Okay, let me just put into start. Oh, what happened? Start all, confirm start. Okay, let me come back here. I'm putting this jar as under home EC2 user as word final, or this time I'll just give my MapReduce.jar, mr.jar, because now we are trying to run the inverted indexing, but with the same jar I can run my word count also. Invert dead, or let me just say map map hyphen reduce dot jar. I also have to pass my word count. I mean to say, sorry, not word count XML, but I have to pass my inverted indexing conf.xml. Okay, let me pass both of the XML files, and I'll show you that with the same word count driver, I will be running sometimes word count problem. By changing the XML file, I will use some different XML file which has a different configuration. It will run inverted indexing. Okay, both have passed it. Cool. Okay, pom.xml also got passed. So we don't require the pom.xml. Let it did the pom.xml. We don't want the my job XML which we have written in the last class. Okay, that's it. Now, once the cluster is up and running, we can deploy our jar. Okay, 77%. Before that, let us also take up a ticket, because I think we might having a stale ticket. That's of 29th. Now we'll take a new ticket from Kerberos, and we've got a new ticket. Okay, no problem. So let's before it comes up. So let us start. Let us write our another problem statement, which is term frequency and inverse term frequency. And I believe in the term frequency, what we wanted to do, find it out that how many times the word has appeared in each file. So something like this. Term frequency, the problem statement, again you go back, but I'm just telling you quickly that what is the term frequency. That uh, right now, okay, term frequency is that how many times, or the frequency of the word in each file. Word count problem was the frequency of a word across all the files. Now I wanted to find the frequency of the word in each file. That means, for example, there is a file 1 where A has appeared, A. File 2, there is 3 words, let's say I'm just taking some words, A, and B. In file 3, there are B, comma B, comma B, comma A. Now when we do a word count problem, we take all the files and we say the count of A is maybe 3 plus 2, 5 plus 6, and the count of B is 4. That's a word count problem. Now what I'm saying, the term frequency says that how frequency of the word in each file. So what is the frequency of the word in A? What is the frequency of the word A in file 1? So you say the frequency of the word in file 1 is 3. What is the frequency of the word A in file 2? It is 2. What is the frequency of the word A in file 3? It is 1. What is the frequency of the word B in file 2? It is 1. What is the frequency of word B in file 3? It is 3. So you have to do this. So how will you do this? So what will be the mapper output? So we have seen that if you want to solve any problem, first and foremost, we have to determine what is the output key value from the mapper. So what should be your output key from mapper, and then also you have to tell me, also you have to identify what should be output value from mapper. Once you identify it, you need to see what you need to figure it out, what should be the output key from reducer. You should be knowing it, output key from, sorry, output value from reducer. Of course, this should be the output value from the output from the reducer, right? This should look like this. So what should be output key from your mapper? It could be combination of your word plus file name, and the output value will be the one, and the reducer can be as good as your word count reducer. Right, guys? I hope you understood this, right? Term frequency is a straightforward problem of it's a straight, or I would say it's a manifestation of your word count problem. In a word count problem, you output the key as a word and the value as one. But in a term frequency the output key value from mapper would be the word and the file name, word and the combination of a file name. That's it. So you will see that how I will use my for this particular term frequency, how I'm gonna use the word count reducer. I mean, I don't have to do with the word. I don't have to actually worry about writing the term frequency reducer. I will just write a term frequency mapper. Oh, very sorry. This what is this? What I did? I have to actually create the package, right? I'm very sorry. Right click new package com.training dot term frequency, and this extend from your extends mapper. As I've told you, we are again going to use the input format as your text input format, default input format, where the key is of type long writable, values of type text, and this should be again text and invertable. We need to get the file name, and we know how to get the file name because we need to acquire a file name. So I'll just take up my this particular code to get how to get the file name, and I'll just paste it over here. Okay, and also I have to actually iterate over all the words, right? And I have to attach the file name to each and every word, so I have to do this as well. In fact, I can take up the entire code and then I will change it accordingly. String input record output key dot set. Okay, great. I will use, I'll create this member variables over here for my reusing the member variables, right? Reusing the variable. I don't want to create every time a new object. I will reuse them. Okay, and iterable. This is iterable, and it is an output will always be a one for me because of classical word count problem, as I've just explained you that how the term frequency needs to be solved. So output will always be one. So I have created a one variable which is anyways will be one. I can make it the final so that it is always one. No one we will change it. What should be my output key? That's interesting, right? What should be my output key? The output key is a combination of your word, and let us put one bifurcation as a hyphen plus file name. That's my key. Combination of a word and the file name. That's it, guys. And I don't have to do anything. Context dot right? And the key becomes my output key, and the value is my output value. And I don't have to worry about my reducer, because the reducer will take this output key and just add the ones. So in this case, it is sufficient to use the word count reducer, which we have already written. The word count reducer, which we have already written here. We will use this because we are going to package in the same project, so we can use it very well. So for that, again, I will say Command C, Command V, and I will now name it as a term frequency conf. Okay, term frequency conf. Let us open that. Q name QA. Okay, these things are same, but the mapper class is our term frequency mapper, right? So I will open my class, select my class, right click on it, copy qualify name, go to your term frequency mapper conf, change it to term frequency mapper. Now reduce class will be the word count reducer I have just explained. So I will use this. I'm not going to write it. I'm reusing my word count reducer to use word count reducer. Number of reducers, let it be one. Output key class is text. Output value class is an iterable. Output from the reducer, output key class is text, but the output value class is my long writable, because word count reducer emits long writable. If you are confused or if you don't remember, you open up your word count reducer, you will see it's a long writable. That's why I'm putting it as a long writable. Input format, text input format. Input directory, again it will be the same Shakespeare directory, and I will change it to term frequency output. Let us build it and send it there. Send it to cluster. Maven clean install. I hope it has, okay, it has already started. Great. So first I'm passing the jar. Okay, the jar has been copied. Then I'll copy all the XML files. Okay, all the XML files are done. Now you see, now let us run one by one. The first will start with the word count job. I think the word count job, I have to actually change the output folder because it was already present. Vi word count.conf. I just change the output. I'll just change the output directory to point to something else. Now you see that without changing the code, I'm gonna run word count problem. I'm gonna run inverted indexing problem. I will run term frequency problem. Okay, so Hadoop jar. Have you changed the job name, by the way, anywhere? Have you changed the job name so that we actually figure it out what is the job name which we are using? Okay, it's not there. Let us add one so that we know that which job is running, right? And I think we have MapReduce, right? MapReduce.job.name. So this is the property. We will actually change it here so that we now next time we will actually will not miss this for other projects. Property name. This is my name, the property name, and the value. And I'm changing the inverted indexing job. So I'll say inverted indexing and mark job. That's my name. I'll cut, copy, paste uh, term frequency. Set term frequency and mark job. Term frequency and mark job. Then what count job. I'll copy these XML files once again to my cluster. Let me verify once again whether with the changes are done or not. Okay, it's done. Hadoop jar MapReduce.jar fully qualified driver class name, and there's only one driver class, that's your word count driver. Right click, copy qualified name, and minus conf. Which one you want to run first? You want to run, let's say, word count. So let us run the word count job. So I'll just provide the word count conf.xml. Oh, I have not changed the, because I have copied back, right? So I have added someone somewhere one. Now it should work. We can view our resource manager UI. You can go to a cluster, click on yarn, and then go to your active resource manager. Click on the resource manager UI link, and you can very well see that uh, it is running the word count and mark job. If it was running only map only job, we have set the explicitly set the number of reducers to 0. Now, what I want to run is now the inverted indexing job without changing the jar. Minus conf. Okay. Now, I want to run this job, and number of reducers I think we have set to 1. We can see it over here. Inverted indexing conf. The inverted index reducer number of reducers are 1. Okay, we can go to our yarn resource manager UI. We can see that currently it is running inverted indexing and mark job. Okay, what we have now, we have to see the output, and let us see the output comes as expected or not. Hadoop fs minus ls. I think Hadoop inverted indexing output was the file name. I don't remember. Okay, this was the file name. And what we'll do, Hadoop fs minus ls, or let me say Hadoop fs minus get inverted output dot. So we'll get into a local file system, and then we will see how the output will look like. So let us see how the output looks like. cd inverted indexing output. You have part hyphen r0. That's since you have written only, since you are run only one reducer, so one output file. And now if you see this, I can see the output. I can tell that the word a appears in all the files: histories, poems, comedies, tragedies, glossaries. The word, let's say, if you see that here, I'm just trying to, okay, this particular word has appeared only in three files: tragedies, histories, and comedies. This word has appeared only in two files: tragedies and poems. And by seeing this output, I can very well tell that which word has appeared in which file. That's complete. So that's how you have it. So that's how you have, I mean to say, that's what the output of inverted indexing problem will look like. Okay, now let me run the term frequency and I just need to just provide that configuration and no changes in the jar, and let us see the term frequency, how does the term frequency output will look like. So as I've explained earlier, the term frequency is, term refers to a word, frequency is count. So the word appearing in each file, how, what is the frequency of the word in each file. And if you want to understand more about term frequency, I would suggest go through my previous class videos, and I have explained in detail that what is term frequency. See the out. So here, that's your output, term frequency output. Again, one output file because you have set as one reducer. And you see this, the 1 in histories has appeared 49 times. The 10 in histories has appeared one time. Let us see for the A. The word A in comedies file has appeared 731 times. The word A in glossary has appeared 28 times. The word A in histories file has appeared 484 times. The word A in poems has appeared 64 times. The word A in tragedies appears in 720 times. Alright, so this is the term frequency problem. So this is what we wanted. Okay, now there was another problem statement in the last class wherein I have asked you to filter the words, use input data, use Shakespeare data as an input, and filter the words or output the words only starting with the vowels. No counting, nothing. You just need to output the words just starting with the vowels. The final output should look like this. Should have some words: a, apple, Aaron, whatever the words, you have seen that, right? whatever the word ends, elephant if it is there, orange if it is there. So all those words just starting with vowel, they should be actually, they should, or you should emit them, or you should actually, I want those five words which are starting with vowels. Okay, so how do we do that? So let us name that particular. Okay, so I will create a package for that, new package, and let me give a com.training.vowel emitter, since we are emitting a vowel. And I'll write my class vowel vowel emitter mapper. Extends mapper. Key in is a long writable. Now I don't explain what is long writable, why it is, because why the long writable text are coming as input, can input value, because my assumption is that we are going to use, or we are going to use a text input format, and the value will be the text. Can anyone tell me what would be the output value? Output key is a text, I understand, because there we are going to emit the output, or they are going to emit the word, so that's why the output is going to be text. Now what's with the value out? I don't want any of the values, and I will be not be requiring any reducer, because my problem statement explicitly says that, boss, you need to output, the final output should consist of only the words that are starting the vowels. Now when I implement the logic, you will only tell me that there is no point of running the reducer, because the filtering logic can be done at the mapper side itself. So here it's a classical, you can say that we are writing a map only job, a job which has only the map task. You don't have to do anything. You are actually wanted to iterate over all the words. Let me take up that word count mapper logic quickly. I'll take up this logic. And where is my meter mapper? What I'm doing here, I'm taking my value into value.toString, splitting on splitting on my slash w plus. If word dot length greater than 1, okay, I'm not don't want to copy. Okay, you can put it as 0, so that we're not counting space. A is also a word, right? So we don't want to miss them. So let's say 0. We are looking out for all those words just starting with 0, and we are not counting space. Okay, so what do we want to do is whether the word starts with a vowel or not. For that, you need to get the first character. String the first character for your word. The first character will be equal to word dot substring 0 comma 1. That will give you the first character of your word. And what you need to do is to check whether the first character is a vowel or not. I will put a switch case on my first character, that's a string, and I have various values. And for the time being, I would like to convert to everything as an uppercase or a lowercase. Let me convert to all uppercase, so that's a uniform. So what should be case A, case E, case I, case O, case U, and you have a break statement, right? And for all this statement you wanted to emit, if it falls into any of this A, E, I, O, U, you just need to emit context dot write the new text of word, and the value is a null writable, because I don't want to emit anything. I just say null. That's it. It's a Java null, right? Again, I don't want to create these kinds of new objects every time. Better to say private, create a member variable which is initialized only once. I'll say output key equal to new text, and then you can reuse this, right? So output key dot set word. and then you pass this. And if it is a default, you don't want to emit that, so you just break it or you don't do anything. That's it. And do you require a reducer for this? We don't require a reducer because I just wanted to output only the words which are starting with AEIOU. That's it. I don't want the reducer. So I will explicitly set the number of reducer tasks to 0. Okay. And what I will do here, copy this and give it a name as a vowel emitter. Conf vowel emitter conf.xml. Open this. The queue name cluster remains the same. The mapper. So vowel emitter mapper. Select your class, right click, copy qualify name, and this is your mapper class. So change it here. Job name, you would like to give it as a vowel emitter MR job. Vowel emitter MR job. There is a no reduce class, so you can remove this. The number of reducers, you're going to explicitly set it as 0 because no reducers are going to run. Output key class is your text, but the output value class, now it's a null writable. So you have seen that, right? We don't want any outputs, so null writable. And there is no point of having reducer output key, reducer output value class. You can delete them. Input format remains the same. Text input format, input directory also remains the same. Output directory, we can change it to vowel emitter output. That's it, right? So we are done. What we'll do is first build the code. And then let us uh, move our jar to cluster and also the XML files. Okay. Also move our XML files. Run our jar with a different XML file. No changes anywhere. Just we are providing our configuration file. Output directory not set. Did we change anything anywhere? What count driver remains the same? What happened here? Minus con. Oh, I'm very sorry. The XML. Right? We have XML. Let us refresh this page to see which job is running. So vowel emitter MR job is running. Hadoop fs minus ls. Vowel emitter output. So we will get it to our local file system. Hadoop fs minus get. Cd vowel emitter output. I hope Now if I do a CD, you know that we have explicited the number of reducers as 0. So you will see the output files coming from the mapper, which you will say part-m. And why do we see 5 output files? Yeah, because there are 5 map tasks for running. And if I want to open one of the output file, you will just see whatever we have expected. That's what we'll see. We just see only the words which are starting with vowels. You can see that here, but we have not done any aggregation because that was not part of our problem statement. Our problem statement was just to emit the words which are starting with what do you say, vowels. Correct? Right. Now, if you wish, you can write a lot of problems, right? Whatever we discussed. Document frequency was another problem statement, and also the average word length. So I hope you have got the idea that how to write different get very small problem statement. But yes, this will give you an hands-on that, or this will give an experience or to think in terms of key value pairs. Given a problem statement, how can I write? So I have left few problem statements for you in the last class, that and so you can go ahead and write those MapReduce job for practice. Okay, so in the next class we will see how to debug our MapReduce job. So right now all the MapReduce jobs are running perfectly fine, right? Because I have written so many times, so I know the code and everything. I have the right; it will not break. But when you're writing for the first time, you don't want to deploy it directly to the cluster, or no one will allow you to directly deploy the cluster, right? No one will allow you to run your job onto your cluster before it before testing. So you how to do the unit testing is nothing but before you deploy you would like to verify on your own side by some means that the output, if you give it this if this is the key value pair, or this is the record if you have given to the mapper, you are expecting some output. So basically I'm trying to say that how do you write the JUnit test cases for your MapReduce job. Okay, previously it was a very difficult because you have to mock the mapper and reducer class. Now you don't have to mock. We will use the some other MR unit framework to test our map code, reducer code, driver code, and everything. So that's all for today, guys. Thank you very much. Let's meet in the next class.